are the ratios 4/3 and 6/5 proportional?
No, because three can go into 6, but you can't do it because 4 doesn't go into 5 without being into a decimal.
Yeah, so 4 doesn't go 4 to 6. To get 4 to turn into 6, we'd have to times it by 1.5.
Yeah, you have to multiply both them by 1.5, but they have to be even.
But if we times 3 by 1.5, we get
7.
3 plus 1.5, which is 4.5.
Yeah.
Not 5. Does that make sense?
Yes.
So we get 4.5, not 5. Therefore, they don't have a common ratio between them.
Yeah.
Yeah? So they're not proportional. Okay.
Do the ratios 5 to 4 and 4 to 3 form a proportion? Let me see. 5, 4, 3, 4. No, because you see, if you add both of them together, 5 and 4, it makes the whole group, and it's 9. But if you do those two together, it will be 7. And they don't. And only 4 can go into 4 by just multiplying by 1. But 3 can't go into 5 without being a decimal or a remainder.
Yeah, exactly. So these ratios, to get 4 to turn into 3, we would times it by 0.75. We would take 3/4.
Mm-hmm. Yeah. Do the ratios.
But to turn 5 into 4, it wouldn't work because we would get 15 over 4, which does not equal 4.
Yeah, and you need to make it to be into the numbers that are exact. Yeah.
Yeah.
It needs to be common.
Yeah, brilliant. Okay, last one.
Yeah. Do the ratios 4 to 5 and 1 to 4 form a proportion? If you add them together, 1 and 4, it can make 5, and 4 can go into 4 by itself. So yes.
Okay, but when we have a ratio, we need to make sure that when we look at them, we're looking at them the right way around. So this one corresponds to this one, and this one corresponds to this one, and we can't just switch the numbers around in case they mean something.
Yeah, it only goes 4 only goes into 5 one time, but with a remainder.
Yeah, so to get 5 to turn into 4, we'd have to times it by 0.8.
Yeah.
But to get 4 to turn into 1, we'd have to times it by 1/4.
Yeah, and you need it.
And they're not equal, so they're not proportional.
Yeah.
Because there's no constant scale factor.
Yeah, it needs to be by with a whole number.
Yeah, you need to be times. It doesn't necessarily need to be a whole number. It just needs to be the same number.
Yeah, the same number.
Yeah.
Factor. It needs to be a factor.
Yeah. For example, if we had 4 and 5 again, but I had think of a number. I don't. One sec. No, I can't think of one off the top of my head. But yeah.
It could be 2 and 4 and 6.
You could have 8 and 10, which would be, or we could have
4 and 6.
4 and not 4 and 6 because we've got 4 and 5. But we could have 400 to 500, timesing them both by 100.
Yeah.
Or we could have 20 to 25, timesing them both by 5. Yeah? Do you see how they've all got common?
Oh yeah. Or 15 and
Yeah, 15 and...
tw- 20. Multiply both of them by 5.
If we multiply them both by 5, we get 20 and 25.
Oh yeah.
But to get 15, we could just times them both by 3.
Yeah, by 3. Oh, so
and then we get 12 and 15.
Yeah, 12 and 15.
Yeah. Can you give us another one?
Yeah. 50 and 55.
50. So if we times, what do we times this by to get the 50?
By 10.
So
Oh, no.
we times by 10.
60 and 50.
Not 60. We've got a 4 here.
It needs to be the same.
Yeah, so we times both sides by 10. So 4 times 10 is 40.
Yeah.
And 5 times 10 is 50.
Oh, so we can do, so for example, we can do 40 and 30 and 40. 4 times 10 is 40, 3 times 10 is 30. Multiply both of them by 10.
We'll try another one. Let's say we use one that you did, 3 to 10.
Yeah.
Okay, so we'll make some ratios that are equivalent to 3 to 10. So I'll just... So, come on then, give me some examples.
3 and... Multiply something that can go. 3 and 5? 2, yeah.
Not quite. So think of a number that we're going to times it by to be our common scale factor.
Okay.
So just think of any number.
2.
2. So we'll times both sides by 2. What do we get?
6 and... Multiply 3 by 6 and 5, no, 10. 20.
20, yeah? Because we do 3 times 2 and 10 times 2.
So both of them have to be multiplied by the same. Why can't we do 5 though?
Why can't we do... We could do 5 if we could... It doesn't necessarily have to be a multiplication, it could be a division. So we could divide by 2 and then we get 1.5 to 5, if that's what you mean.
Yeah.
Yeah? Come on then, give me another one.
By 3.
Yeah, times by 3, and then what do we get if we times both by 3?
9 and 30.
Yeah, brilliant. We could pick a totally random one. We could times it both by 12, for example, and then we'd get 36.
And 36 and 120.
Yeah. So can you see all of these ratios that we've written now are all proportional to 3/10?
Yeah.
Because they all have something in common, a common number that turns them into that.
They all have to. Yeah. Right.
Yeah? Okay, so that was just like a little thing that I thought we should do just to sort of fill in a gap that I might have left. So we could either, for the last 15 minutes, go on to the same topic. In fact, we'll just do this. I'll just introduce you. And if you don't understand, then it doesn't really matter, because we can come back to it. So this is very, very similar. The same topic as proportions, but it's like a new way to do it. It's a new way that we can use what we know about proportions to work things out with graphs.
So a new method, yes.
Yeah, like a new method.
So we can
So in your workbook somewhere, there's probably a page on direct proportion, maybe.
Yeah,
There probably is. So I'm going to just give you a little introduction, if you like, into the world of direct proportion.
Okay.
Yeah? You can have a look later to see if there's a workbook page similar.
Okay.
Yeah? Okay, so here is this question again.
Let me scroll down.
So number 1 on the yellow direct proportion.
And you bought 6 souvenirs. Yeah.
Yeah, so we've already done this one.
We've done that.
In the recap,
Yeah.
we did it like this. 6 souvenirs is 2 days, 9 souvenirs is 3 days, times them both by 1.5.
Yeah. We did the.
Yeah.
Yeah.
Yeah? So the new method, if you like, is doing this direct proportion thing. And what it means is we can write things. So I'll just show you an example of how to do it first and just try and follow along.
Okay.
So this question tells us that the relationship between souvenirs and days of holiday are directly proportional.
Okay.
So we can write, you might have seen this before, you might not have seen it before. Souvenirs is directly proportional to days of holiday, and we use this symbol.
Okay.
Direct proportion is equal to this symbol, and it looks like a little fish, I guess.
Yeah.
Yeah? And then what we do is we can rewrite this as souvenirs we can turn this into equals K equals K times the number of days of holiday,
Yes.
where K is the scale factor, or it's just a number that we don't know.
Okay.
So K is,
It's the missing that we have to find out.
yeah, like a missing value that relates them both, makes them proportional.
Yeah.
Okay, so
Okay.
so then we can substitute in what we do know, because we have some information given in the question.
Yeah.
That 6 souvenirs makes 2 days of holiday, yeah? So we can write 6 souvenirs equals K times 2 days of holiday.
Yeah. So, okay, 3.
Yeah? So yeah, so exactly, yeah. So then K is equal to
3.
3.
Yeah.
So for every souvenir, there's
There's
3 days of holiday.
Yeah. So 3, and then if it's, yeah.
Yeah? And then the new equation that we've got, we can directly write souvenirs. We can write that in words by replacing the K. Souvenirs
Yeah.
equals 3 times days of holiday.
Yeah. So,
Because we've worked out what K is.
so how many days it says, you multiply it by that.
Yeah.
So
And that works because after 3 days of holiday, how many souvenirs will we have then?
9.
9. And just to check with what we did at the beginning, we got the same answer?
Yeah.
9 souvenirs is 3 days?
Yes, because
Yeah.
you multiplied it by 3, so 3 times 3 is 9.
Yeah. So in this case, we times it by 1.5, but we could have times it by